So good morning everybody. I am Jayashree from SNS College of Technology from the Department of Biomedical Engineering. So I am going to take analog and digital integrator circuits. So the unit name is what? Sequential circuits. The topic is what? Serial in, serial out shift registers. So let us see what do you mean by SISO shift registers. So before this we recall the flip-flops and what is the need for SISO and why SISO operations. So let us recall these topics. Before shift register they use the flip-flops. Early digital biomedical devices like basic signal processing for medical imaging began using this ICs. But power and size constraints limited their adaptation in portable systems. So next, empathize. So empathize real world in biomedical need. So empathize stage, real world biomedical need. The user pain points, the biomedical devices such as wearable heart monitors or neural implants and often face issues with high power consumption leading to frequent battery replacement or discomfort for patients. So focus on applications ECG and EEG signal delay and buffering, whereas SISO shift registers can store and shift data serially to reduce power in the portable devices. That is what SISO shift register, it can transfer data serially. Next one is what? Define stage. So define stage is what? Develop the low power SISO shift registers for biomedical signal processing that address high energy source used in traditional CMOS based circuits, enabling longer battery life in implants and wearables. Target applications in low power serial links for biomedical sensors networks, whereas data from biomedical sensor is shifted serially for transmission. Next one is what? Basic structure, and this is what the pin diagram of this SISO. So all flip-flop receives the common clock signal, that is what? Synchronous transmission. So all the flip-flops receives the common clock from this clock signal and the inputs D2 to D3 are loaded simultaneously and the outputs Q0 to Q3 are available by 1. Next one is what? Ideate stage. So ideate stage tailored for low power data storage in neural interface or wearable biosensors. So validation, there is user needs. Number one is what? Medical devices and design output and design process, design output, design input. The user can give the needs through the design input stage team and design input stage gives the design process and finally it goes the design output and verification. If it is not satisfied, it will again do the design input. And finally we get this review of all these parameters. That is what this ideate stage. So validation, verification and testing and finally review. Next one is what? Prototype. So using QCA Pro for energy analysis and verify waveforms showing data shift on clock edges, refinements, optimize cell count and area for better integration in compact biomedical integrator circuits. It ensures reliability in applications like data buffering in smart biosensing variables. Next one is what? Testing, that is validation and biomedical applications. Testing results. Simulation confirms functionality with low power, cost function lowest among peers. This feedback loop, iterate based on biomedical user test. Example, integration in serial link for sensor networks. Next one is what? Assessment. User need for identify during the empathize stage of the design thinking process for the lower power SISO register. In the design thinking process for the shift register, what is the main goal of the define stage? And which of this concept was proposed during ideate stage for the SISO register design? So thank you all. Have a great day.